So I'm going to bring you somebody I've already been speaking to. If you watch the promotional video, I interviewed John, and actually his interview's up on the Space Careers portal on the ESERO website. And John Ward, you're very welcome to join us this morning. And John works at Réaltra. How are you? It looks like you're in a very sunny spot. Where are you, John?
Yeah. For once, we actually get some sunshine here, so I have the blinds down. But thanks for having me, Niamh.
Very nice. No, it's great. And you are a systems engineer, but tell us about your career. And I'm sure you're going to mention James Webb at some stage in it, but tell us about how you got to have such an exciting job that you did.
Well, do you want me to start the presentation, or do I just?
No, whatever way you want to do it.
I think I'll tell the story probably a little bit through my presentation here, and I will share that now. So let me know if you can see that. Okay.
I can see that fine. Yeah.
Yeah, super. So as Niamh actually mentioned there, showed this beautiful video of the James Webb Space Telescope as it's drifting away from the top of the Ariane 5. And that video came from a system that was conceived of and built in and tested in Ireland by Réaltra, by the company I work for. So my name's Johnny Ward, and I started my career as an astrophysicist in academia for several years before I transitioned into engineering. And I'll kind of, give you that whole meandering path of my career. But before I started, the first thing I wanted to say is that for all the students watching, that this is just my story in STEM. And so I'm from Donegal. I'm from a different generation to everyone watching this, because none of you were born probably when I was starting secondary school. But so what that means is I have my own unique upbringing, and so I had different challenges and different advantages, and good luck and bad luck relative to you. So what I'm going to tell you is not the correct way to have a STEM career. It's just one way, and so you'll all figure out your own ways about how you want to enter into this world. And the other thing as well is be a little bit wary if you're comparing yourself to me. For example, I have years and years more experience than anyone, and I'm only showing you all these beautiful pictures and successful moments, but there was plenty of bad moments as well, which I might dip into. And then one little bit of advice I often found, and this helped me a lot throughout my career, was I had to stop sometimes and ask myself some very deep questions, but they were essentially, what did I specifically like about what I was doing? And what I mean by that is, if I'm working with my hands in a lab, what is it? Is it exactly that I enjoy doing? And do I need to be in the job I'm doing, or do I need to be in academia to do that job? For example, could I, an engineering context in a startup? And so those are questions that I had to ask myself throughout my career. And it's something I think it's important to ask while you're making these decisions. One little bit is just beware your ego when it comes to making STEM choices. So some things you can find is you have to be very careful about your motivations for why you're picking stuff. And if you're saying you want to be a physicist because people will think I'm smart, that's not a great long-term motivation, because when you're in a difficult situation, when the pressure's on, or when you're struggling to solve a problem, that's not the thing that's going to make you work harder, just because you're relying on other people's input for your own self-esteem and for your own self-fulfillment. So that's something I'm going to try and maybe bring into here. I have another slide which kind of just maps out essentially my career to date, which is, perhaps not typical, but it is typical in the academic context, because academia is a bit of a nomadic lifestyle. You have to move from university to university while you try and find a permanent job, and then industry can be a little bit more stable. But from the very early days, I was interested in kind of the night sky. And that's, I really think, because of my environment. So I grew up in Glenties in County Donegal, which is actually, I think, designated a dark sky area, meaning very little light pollution. So for me, growing up, I was exposed to a pretty phenomenal night sky when it wasn't raining in Donegal. So that was pretty rare. But my father would bring me out with a small telescope, and we would go stargazing. So I think from a young age, that already started to instill a kind of an interest in the universe and astrophysics as such. But when I was in secondary school, I did many subjects, and we could talk about that later. But one thing I did focus on a little bit was taking honors physics and honors mathematics. But I did other subjects, of course, and I think something we can talk about is that it's important as well to stimulate your brain, because imagination is a crucial part of being a scientist or an engineer. You have to have the ability to think outside the box, and so things like music and art, I think, are critical to that. Ultimately, then when I was in secondary school and thinking about, okay, I'm kind of good at physics, or at least I enjoy it. Is there something I can do here to give me a career out of this? And so I did a Bachelor of Science in Maynooth, which is in physics with astrophysics. Now, even at that stage, I was thinking, well, okay, physics is a useful degree because at the very least, it'll give me options to move into various industries. So if things go wrong, or if I realize maybe a career in physics isn't for me, well, at the very least, because of the training you learn as a physicist, as a problem solver, it could be something that could be very useful in many fields. And I have many friends who've done this degree and they work as managers in Aldi, or they work for Google. But all of those roles involve problem solving. And I think being a physicist helps you train for that. Throughout this as well, there's moments that I think are really important. And some of them were getting internships at Chicago, for example. I'll speak a little bit about that. But a lot of those things help differentiate your CV. So everyone is a lot of people are doing third level degrees, and that's fine. It's a good basis for everything. But sometimes you need that little special sauce, and that could be done through an internship or some projects that you do. And so a lot of my career was informed by taking a risk and emailing people and trying to find out, do you need someone that can do this, or can I work here, just to start adding on in my CV a little bit and differentiate me. But you can see throughout my career, I had to move to the United States. I worked at NASA Goddard for 6 months as part of an experiment there. Then I moved to Spain in Réaltra, which is outside of Barcelona, but I worked at an institute there, and that involved telescopes in La Palma. And then I moved into industry. So at a certain moment, I went, I don't know if academia is going to work for me. I don't know if I'm going to get the permanent job that I need. So I'm going to take all the skills I have from academia and see, can I transition into something that I still find enjoyable, which is space-related work, but it's actually in the engineering side. And so I went into a startup company there in Barcelona, and then kind of after 8.5 years away from Ireland, wanted to come home. And luckily, Réaltra Space Systems Engineering was just starting. And I sent an email through their website to see were they looking for somebody, and I got a response. And a week later, I had an interview in Dublin, and a month later, I had moved. So the thing here is that just to show that this is all kind of it was never all smooth, and there was a lot of little fluctuations in terms of my career. But ultimately, this last slide, the last logo won't be my last, and maybe that I'll change job again. You can already see I'm a space product manager now, and maybe in the future it'll be a completely different thing. But the one thing I wanted to show is that there's 25 years here. I started secondary school in 1997, which terrified me when I wrote this out. But there's a lot here. And so I'm going to have to blast through my slides because I have a lot to say. But one of these things when I talked about was this University of Chicago internship. So these were moments that gave me some really great experience early on. And what actually informed a lot of my research was cosmic ray physics. Now, a cosmic ray, it's a particle that comes from outer space. There's a rain of these that hit our Earth constantly with huge energies. They travel near the light, a lot of them, parts of elements. And what's an element? Iron, a strontium particle, a gold particle, silicon. All of these atoms are raining down on us. And for a long time, we had no idea really where they were coming from or how they got this energy. So how do you measure these, or how do you study them? Well, you build a detector, you put it on a giant balloon here, which is the stratospheric balloon, they call it, which brings your detector to 40 kilometers above the Earth. And that means that the atmosphere is no longer blocking these particles. The atmosphere acts like a meter of lead in terms of blocking radiation. So if you want to measure these particles, you have to get above that. But early on, what that gave me was this great experience as an undergraduate. I got to work with real experiments. I got to order parts, put them together, and work in very high pressure situations, such as when this is launching, monitoring the payload and stuff. And then this was me when I was much younger with more hair, And you'll see a lot of photos of me with Donegal jerseys, so apologies for that if that triggers anybody. But this was a launch from S-Range in Kiruna in the Swedish Arctic, so really incredible experience at a young age. Then I moved on into gamma ray astronomy. So Niamh had shown you the electromagnetic spectrum, and in the corner at the very, very highest energies are gamma rays. So these are the radiation that turned the Hulk or Bruce Banner into the Hulk as such. But this allowed me to again keep working on cosmic ray origins, because weirdly, when these particles smack into each other with such high energy, they actually generate gamma rays. So when you're searching the universe for gamma radiation, it's like looking for the smoke of a fire. And so this brought me to Arizona for several months, and also to La Palma, where I worked on the MAGIC experiment, and Veritas was the experiment in Arizona, which Dublin and Ireland was actually one of the pioneering countries involved in this entire field. But for students, okay, that's very cool. However, what do you actually learn from all this work? Ultimately, with gamma ray astronomy, what you end up doing is you analyze data. So what that means is you collect these gamma rays, but you have to write programs to clean the data and make these beautiful little sky maps here. So what in the bottom left you have here is the Milky Way, our galaxy, with gamma ray eyes. So this shows you lots of little exploding stars, which we believe cause these cosmic rays to exist. And then when they hit into each other, you get this gamma ray glow. And this is actually the top right here. These are is the black hole in the center of our galaxy. Now, yes, you can't see a black hole, but all the material spinning around it and falling into it actually generates gamma radiation. And so these are maps of that. But what this work helped me learn was, programming languages, presentation skills. So when you're presenting your results to the scientific community, documentation writing, so writing scientific papers, clear, concise language, getting your message across. Teamwork, these are big experiments, hundreds of people, technicians, engineers, and scientists. You all have to work together to make sure that this system works so that you can make these beautiful images. Furthermore, then in the stratospheric ballooning thing, so this was really the core of my academic career. I would say I worked on something called the Super Tiger experiment, which was again about detecting cosmic radiation, cosmic rays, and trying to understand where they were coming from. And this is where I really started to get the engineering bug, because you can see here we were making these types of detectors which would allow us to know when a particle entered and exited our entire detector stack, which you can see examples of here. A lot of electronics work and debugging that. Then environmental testing. So you can see on the right-hand side, this is a huge chamber which they suck all the air out of to, well, nearly all the air out of, to simulate the environment that our balloon experiment. When you're above 40 kilometers, you're above 99.9% of the atmosphere. So it's nearly space. But we want to see, does our experiment work when you remove all the air out of the system? And so this was already this environmental testing I'll talk a little bit about, because it's extremely important in the context of space engineering. You have to test your system to make sure it'll work in space, because you can't get up to fix it. And again, the other, always data analysis and programming, and a lot of teamwork. So again, you see this is only partially the team. But really then we had to launch this thing, and we went to Antarctica. Now, why Antarctica? You go to Antarctica because in the summer months in Antarctica, the wind pattern sets up in a cycle. And when you put your experiment on a big balloon, it means it goes around in circles. And if it falls off the balloon, it's not going to fall on anybody's head. And so we ended up flying, because I was with the United States University, Washington University. We flew down with the US Air Force, and we built our experiment up again down there. And again, this is the team, the Super Tiger team. So it wasn't just me, I was part of a team, and we all had to support each other and make sure that we got what we needed done. Here's the bottom right, the balloon inflating, and in the right there is Mount Erebus, which is actually the most southerly active volcano in the world. So always kind of looking nervously over at it while it was smoking. Here I'm just going to quickly show you, because I'm mindful of time, that we launched. This is an example of launching a stratospheric balloon. So you can see it releases. I don't know if you saw the Super Tiger experiment with us standing in front of it, how big it was. So this just gives you a sense. That's it down in the bottom left on that little crane. So this just gives you a sense of how big these balloons are. So that's the Super Tiger experiment there. And then what happens is, at a certain moment, they decide that the wind has caught the balloon and you're going to let it go. And once that balloon gets up to the upper atmosphere, it inflates so much that you could actually fit Croke Park inside of that balloon. So that just gives you a sense of how ginormous those are. Now, that's all cool, lots of nice photos. But what do you do when you launch your balloon? Well, you have to monitor the experiment, make sure that it's working. I was down there for 96 days in total, but 55 of those days was simply looking at the performance of the experiment to make sure that we monitored all the housekeeping, which means all the vital. It was working. And there's 3 orbits around Antarctica of the balloon, so they're just different colors. And in the end, you could see it landed up there. I grew a very big beard. You go and look.
I think we've lost him. Have we? Is it me or has?
I also cannot hear him anymore. I was wondering if it was my internet.
I thought it was mine as well.
Yeah.
So not to worry. I mean, John's talk is fascinating. I mean, he's had an incredible career at the Antarctic. I was so jealous when I was interviewing for the video. If we've lost John, you can watch you can watch him talk on the video that we have. Stephanie's actually just put it in the chat there. So you have it there on the ESERO Space Careers portal. He's had a fantastic, really fascinating career, and he's moved into industry, and I'm sure he was going to tell us that. And there's some really great nuggets there in what he was sharing. I think he's coming back in. Let's see if we've time for him to tell us the rest of it. We are running a little short on time, but hopefully. Hi, John, you're grand. Hey. Don't worry. I was just talking. So you're grand. So if you want to finish if you just want to finish up, we'd love to hear the end of your presentation. It's fascinating what you've been doing already. So I'm going to stop talking. Take over there.
Okay, sorry. So can everyone hear me okay still?
Yeah, we can hear you. Just pause for a second. That's
okay,
all.
Okay. So one thing I'm going to just briefly talk about is that in Réaltra, you're making these video kits. And one example of what I show you is that you need to build your electronics very carefully, but you have to test them. And so one of the jobs I do now is we drop a giant hammer onto pieces of metal, which simulates a shock on the rocket. And you can see this is one of the cameras we referred to in the JWST here. So this is the type of work I do now.
You just need to share, if you share your screen again, John.
See, sorry, excuse me.
No problem, no problem at all.
Of course. It's disabled. Can someone let me share?
Oh no. Yeah, Robert, Danielle, can you give John sharing privileges again? There you go. Off you go. You're the co-host. Go.
Okay. Yeah, sorry. So one of the things, again, we do with testing the video kit for Vicky, for example, and this is the example of the video system here. It's one of the cameras, but we have to make sure it can survive the environment of space. So one of the tests I end up doing here is that we drop a giant hammer on the, let me do it again, drop a giant hammer next to our camera, which you can see here on the left. And that then simulates the shock that happens when the cone of the rocket blows off. And so this is the type of work we end up doing there. So document thing that unfortunately you're going to have to deal with. So lots of work about making sure that your experiment does what it's supposed to, that it can survive the environment of space and arrives on time within budget. So a lot of reading of documents. And this is always the meme I like because this is what I actually do. Cool photos, but there's a lot of Word and Excel documents. So the only core point, just to summarize here, is email, phone, make connections. You have nothing to lose by reaching out to people. No one's going to give out to you. Be shameless, because that way you'll end up putting yourselves in positions to get jobs and to get internships. Helps with your CV. And then other things you can do in STEM. There's health, law, art, business, journalism. It's an industry. So you need all the pieces to work in this industry. And in the Irish space industry specifically, we're growing at a big rate, but we need engineers and physicists and entrepreneurs and all this type of stuff. So please consider this career. And it's a lot of fun, and it's important now because Ireland is the space industry is growing and we need you. Yeah. So thanks for your attention. Sorry that took a long time. and here's my Twitter handles, etc. So feel free to reach out.
Just leave them up for a second as we're finishing up so that people can see them. That's terrific. I'm so jealous that you got to work in Antarctica and the Arctic as well. So you've had a really varied career, and you've summarized it really well, and it is a personal journey and a personal quest, but I think you're a perfect example of somebody who just thought outside the box and reached out and thought about internships, and that's what's gotten you where you are today. So thank you for sharing. But we'll go into more detail when we get into the breakout room. So don't forget, you can ask John any questions you want. There's actually a prize for best question coming up shortly when we after we hear from Giovanna. So John, thank you so much. If you unshare your screen there, I might bring Giovanna forward. Stephanie, have you anything that you want to say, or you just
I just wanted to reiterate, because I thought it was really interesting. A quote from John was, imagination is a crucial part of being a scientist or an engineer, problem solving and thinking outside the box. And I think if people take that message home today and nothing else, I think that is a really powerful message to take away from today.
Thanks, and thanks, Sean. Yeah, because sometimes it's hard for people to understand what an engineer does, but I think you've captured it really, really well. So thanks, John.